Okay, and now lecture 2 on the same topic, that being writing formula weights and doing some calculations. So if you don't have a calculator, get one, okay? And always have that at the ready. And those of you coming on Monday and Tuesday, bring it to school with you, okay? Because you can see here that, as we do some of these problems, they're going to get more and more complicated. I'll try to continually remind you of that. Okay, so let's go from where we left off with the last lecture, that being taking table salt, doing the circle square methods, and ending up with that one single correct answer. And the actual circle square method is worth points and is required as well. Okay, so I want you to get in good habits early on and minimize the small mistakes that are often made with doing these types of calculations. So let's do one that has a little more difficulty to it, please. I'm just asking nicely. So what is the formula weight of aluminum tartrate? So a lot of you are like, tartrate, what? No. So that's where, oh no, I'm going to use the subliminal feature again. See if you can guess where you're going to find tartrate. Here it is. Any guesses? That's right. That's right. You're going to find tartrate, and you're going to find the charge of aluminum. You're not going to just guess what the formula of something. You remember, I think we watched about 6 or 7 lectures. Some of you, it's been a little while, but again, this is a skill that I think you should just possess for the long haul. Find that aluminum on there, +3. Tartrate, turns out, is C4H4O6 with a -2 charge. You're going to have to crisscross that 2 and 3 to get a +6 and a -6. So the correct formula is Al2 C4H4O6 in parentheses 3. So remember, this 3 is going to carry through all these things. So that's actually 4 carbons times 3, which is 12 carbons, 12 hydrogens, and 18 oxygens. So we still go one place to the right. Okay? So I want you to hit the pause right now and give this a try. Okay, so hopefully you saw that when we do this, there's 2 aluminums. You saw one was 27.0. You can write that number down too if you wish. I don't think it's necessary. You just take it off the periodic table, one place to the right. There's 2 of them. That's 54.0. Okay, remember 12 carbons, 12.0 each. That's a total of 144.0. So don't feel bad if you didn't get this time. You might not have understood that you're doing the grand total of each individual atom in the circle. But that's what this amounts to. Sodium chloride was a simple one. This one you just have more of them. 12 hydrogens. Hydrogen's an easy one, 1.0. So that gives you 12.0. 16.0 for oxygen. You're going to do a lot of those. You got to multiply that out. You can see where having that calculator is probably going to be a nice thing. Unless you can do, those kinds of things in your head. But it's going to cost you some time. So you're always going to want to have that calculator with you. So now you got all your circles. All you got to do is add them up, and you get 498. Now, you have to be careful here, because we agreed. We voted on this, remember? Virtually. And we said one place to the right. So you can't write 498. And you're like, well, that has the same numerical value as 498.0. Nuh-uh-uh-uh. That is a very important 0 there. That's why it's a significant digit. So 498.0. Trailing zeros on that side are significant. So we must be done right now. I advanced it and nothing happened, which means the answer is wrong. Actually, 2 points off so far. What are we missing? See if you can think about that. Answer, grams per mole. And, of course, if you're doing the circle square method, you can't leave out the square. Okay? 498.0 grams per mole. All right? So, you're going to get a chance to practice several of these, some where you have to write the formula, others where you can jump right in, and we are really trying to achieve perfection on these. There should be no variation in your answer because we're agreeing on the same system. So your setup, when you do a problem like this, obviously the formula, take your time to get all the little components of that right. All these point zeros, people tend to want to leave those off. They're significant. They're very important. So make sure that you include those and put that box around your final answer. Okay? So now we're going to try this one and make sure you're writing the problems down again. So we're going to do magnesium chloride dihydrate. Well, all these formulas have been two-word names, like magnesium chloride. That dihydrate is a little curveball I threw right there. A little slider. So let's figure that out. And you can actually use some logic to figure that out, but there are some rules to follow when writing the formula. Obviously, we'll start with magnesium chloride. That's something that you know. Grab that yellow sheet. Don't just write MgCl, because if you write MgCl, it would be wrong, because it turns out magnesium is +2 and chloride is -1. So it's got to be MgCl2. So what is the deal with this dihydrate thing? Well, let's try advanced. I'm going to go advanced subliminal feature here and see if I can give you some hints to figure out what dihydrate means. Any thoughts? If you're thinking, after watching the subliminal thing, that it's 2 water molecules, you are correct. So how do we write that in a formula? Boom. Dot 2 H2O. That's not a times. It is a symbol used in the formula. So MgCl2 dot 2 H2O. Okay? Now, remember, before you crunch all these numbers, this is 2 water molecules. So that 2 carries all the way through as if it was a parenthesis and the number was on the outside of it. Because this is a, like when we were balancing equations, which was the very last thing we did, and we put those big coefficients out front. That means 2 water molecules. You remember your subliminal thing. It'll tell you that. So, given that information, hit the pause, and now I think you can go 4 for 4 on your circles and 1 for 1 on your square. Finish it all the way to the end, and let's see if we can figure out if you are making any little mistakes early on before we turn you loose on the worksheet. All right, welcome back from the pause. If you haven't paused, do it now. Otherwise, welcome back. We've got 4 different circles to do. The magnesium's 24.3. Each chlorine is 35.5. When you double that, your stupid calculator is going to say 71, but you know better. It's really 71.0. Now, here's where people tend to make mistakes, especially on the oxygen for some reason. I think they see the 2 and they're like, yep, it's 4H and then that oxygen. But that 2 oxygen, so hopefully you got that one right. And you got that as a 32.0. And if you got all 4 of those right, I'm guessing you probably got the 131.3 grams per mole correct as well. That is a formula weight of a hydrate. Okay, a hydrate has water in it. We're going to be doing a lab. Yes, lab, finally. A lab next week that deals with taking water out of a hydrate and doing some calculations in the lab. Okay, so there it is, right there in front of you. Okay, so that is a little bit of some notes from our lab. So we're going to stop this lecture right here, and you're going to do what amounts to the first page of what we call the mole worksheet series. You're just going to be doing page 1, and then you're going to be correcting it. Okay, so that is what our assignment is for tomorrow, and then for Monday, make sure you're done. And then if I can monitor you on GoGuardian, you don't have to submit anything. Cool. So hopefully you have good notes and you got this worksheet all done and corrected. And then if you did, you're going to get your points for today. So good job on that. And we're going to apply this with some percent composition starting on Monday. So have yourself a super duper weekend. All right. Take care and stay warm. Ooh, it's going to be cold.